Hello, everyone who's already here. Welcome to Intro to Data Science in R. We'll be sitting tight for just a couple of minutes to let people kind of trickle in, get settled into this workshop. This is the second last day of Gear Up for Hack the North 2021, so really exciting stuff. Been a great week so far and looking forward to going through this today. So yeah, feel free to get settled in, kind of get all your tabs ready, get comfortable, put on a hoodie or something, and we'll get underway in just a couple of minutes. If you are tuning in through Hopin or through YouTube, hello. Feel free to pull up the Hack Pack, which has a couple of helpful tips. With this workshop, there is no setup required beforehand, so don't worry about like installing something or getting any environment set up. We'll be doing everything through the browser with something called Google Collab, which is really cool. You'll get to see that in just a little bit. For anybody who's just joined, we'll get started in about a minute or so, chatting about Intro to Data Science in R today. So yeah. We also are using Slido for kind of Q&A throughout the workshop. So feel free to pull up that link and have that ready in case you want to ping me. And as always, if you aren't already, you can join the Hack the North Discord, and I'll be on there as well. If you have any questions, you can always ping me. So just another minute or so till we get underway. Lots of really good content to dive into today. Hope you guys all had a good day. For me, it is 3 p.m., so it feels much earlier. If you're in Eastern time, which I imagine many people are who are tuning in, it'd be 6, so a lot later for you than for I, but wherever you are, welcome. All right, so it looks like it's 3:03 or 6:03 now, so we'll get underway with the workshop, and if anybody tunes in, they'll be able to join right along. So welcome everyone again to Intro to Data Science in R. Today, hopefully, we're going to be taking your first few steps or building on your first few steps in data science, explore an existing data set, creating a first model, and then talking about how we can deploy it and make it useful for others. So this workshop is loosely inspired by Neil deGrasse Tyson's book, Astrophysics for People in a Hurry. I know very, very little about astrophysics, but I do know a fair bit about data science. So that'll be the theme of today. It is going to definitely be fast, but this again is just an intro. We're hoping to write your first few lines of R code, or maybe you've had a little bit of experience but want to kind of get a more solid foundation, and then also learn about some key data science terms. So that's the goal for today. It's also a very hands-on workshop. So we're going to be working through a Jupyter notebook style document together. So you'll be able to write code, not just kind of watch me write code, which hopefully should be a bit more fun for the workshop. So without further ado, my name is Michael. I'm a third-year computer science student and data science student at the University of British Columbia in Vancouver, so a couple time zones away. I just finished working as a software engineer intern at Samsung this past summer, and I've been TAing for quite a bit now. 2 fun facts about me is that I'm left-handed and have a pet tortoise named Leo. So yeah, that's a little bit about me. Feel free to connect with me on any social media. I'm Michael from YEG on about everything. Yeah, and also same thing on Discord in case you're looking to reach me there. So the agenda for today is as follows. You can kind of follow along on the bottom of the slides to see the 4 major modules of today's workshop. Right now, I'm just kind of doing a little intro, and then I'm about to move into a background to data science, where we'll kind of cover the theory needed for today's workshop. Then we're going to get Collabin. We're going to work in a Google Colab file together to start writing your first few lines and go all the way from what is a variable in R, all the way to a first model, which would be really cool. And then finally, we'll have a quick bit of time at the end to just wrap up and ask any questions you might have. So that's the outline for today. So welcome. What are we going to be talking about today? Well, today we're going to be talking about data science and then data science in R. Those are kind of two distinct things. And so, with that, we should be setting goals to see what we want to get out of today's workshop. So there's a few main things I hope that you can take away from today. One is describe at a high level what data science is all about. What is the goal of the kind of field? What are the major principles of data science, and what does it mean to be a data scientist? The second is to write and read some basic R code that reads, explores, and processes data sets. Processes being a very kind of vague term for making models or making graphs or making just about anything. And then finally, we want to take those models we produce at the very tail end of our workshop and make them useful. So we want to find ways of publishing our results to others and making them accessible, perhaps through an API or through a report or through any other means to kind of communicate what we found. So those are our three goals for today. So yeah, just jumping right into it, what is data science? So the goal of data science is to extract insight from data. So there's two pieces there. Let's break them both down. Data is just really any fact or statistic in the world. It could be a variety of things. To stick with an example, we could talk about a house. There's lots of different data points associated with a house. You could think of its color, which is like kind of one of many different types. We usually call that categorical, falls into one of many categories. So your house could be red or blue or any other amount of discrete values. Houses also have kind of numerical quantities associated with them. So for example, like the number of rooms, which are kind of whole numbers, or you could talk about the price of a house. So like some sort of dollar amount that's continuous. You could theoretically have cents in the dollar amount of your house. So those are all kind of different data points we'd associate with a house. And there is data literally everywhere. So much data that it's impossible to process by hand. If I ask you to go through all of the past search queries people have punched into Google and make something useful out of them, kind of make the queries better, a human would have to write quite a few if-else statements, have to write quite a few, I don't even know what, to make that effective. It'd just be too much data for us to process. So data science is about creating workflows to make that data useful and keep our sanity in the process. So there's a number of steps involved. You can kind of see on this picture on the right-hand side, which really is the whole field in a nutshell. We begin by creating a hypothesis, like in any science, so a kind of guess about the way the world is. We get some data, we transform it into a way that's usable for us, we visualize it, we create our model, and then finally we analyze our results. So let's go through and unpack each of those steps. So the first one is asking a question, right? We're kind of trying to form a hypothesis about the world. We need to ask some sort of question about, like, what do we want to study? There are tons of different kinds of questions you could ask. A common one that we see in data science is something that's exploratory. So is some variable X related to some variable Y in some way? So sticking with the house example, is the number of bathrooms in a house correlated to the price of the house? Are those two things linked in some way? And this is something actually with today's exploration that we'll be able to answer. We'll be able to say, okay, like, are these two things linked? And I'll give you kind of the tools to get a better understanding of what the relationship between two values is. You could also ask causal questions, like, does the, I don't know, one more bathroom in a house cause the price of a house to go up by $50,000? Those like really targeted questions that are kind of cause and effect based, like you'd see in like a history course or something, we can't really answer with the tools we'll learn today. There are other ways, sure, of studying those kinds of things, but that isn't the goal of today's workshop. We're focused on kind of the high level exploratory questions, but we can't get into the nitty gritty of cause and effect. So do be careful when forming your questions. The next step is to collect some data. So there's tons of different sources we could use. We could use a kind of spreadsheet file. So you might have seen .csv. That's short for comma separated values. And those you could open in Google Sheets or Excel or anything else. And so those are a very common source of data, and actually the one we'll be using today. You could also have databases. So if you have huge amounts of data, say like petabytes of data, we probably would want to store them on some kind of remote database. And so then we'd have to import that data and work with it. We could also scrape data from the web. So if we had data on, say, like a Wikipedia page that we wanted to access, but it wasn't available to us in a database or in a file format, we could actually go to the web page itself, and using a couple of different tools and a bit of knowledge about HTML, we could scrape the data from that page, which is also quite cool. There are some kind of ethical concerns with that, so do be careful before you go scraping and make sure it's like allowed. But that's also a common data source. You can also collect data yourself, and there's a whole kind of field of statistics dedicated to this, so I won't dive into it here, but you could do surveys or do studies and get data that way. And then the next step of reading in the data into R is fairly straightforward, and we'll see that's just a few lines of code, typically in most projects. The next major step is to do what's called wrangling data. Sounds kind of like Western cowboyish. It's not that exciting. What we do with data wrangling is we take the data in the form it was on, say, the database or within the file, and we convert it into a form that's useful for us. So we might have to filter down the data. We might have to only select certain columns that we're interested in. We might want to group the data by a certain category. We might want to summarize the data, so get things like the mean, the max, the min. Those are all different ways we could sort of wrangle the data. There is a concept known as tidy data that I won't dive into here, but that's worth kind of Googling and poking at in your own time, going kind of beyond this workshop. And usually in the wrangling step and cleaning the data, we're looking to make it tidy. Next up, you can see kind of after the arrow is visualizing the data as well. And that just means producing a graph or a chart, very straightforward and something you've probably seen before in a classroom. The next step is a model. So a model is a tool to take a pre-existing data and use that to generate insights. So it could be an insight that's like a new prediction. So for example, given a brand new house with a number of bathrooms, can I predict what its price might be, or what a reasonable price might be to charge others? It could also be things to do where we don't have an exact thing to predict. So for example, given customers' past purchases on Amazon.ca, you could then see what a next product to recommend might be. And that there isn't necessarily a right or wrong answer. It's not something we can necessarily point to and say this is like the dollar value, but is a similar kind of question that we can do. And that would also be using a model. This gets really complex really fast. You can see kind of in this picture I borrowed from a textbook, it's like 5 chapters of this textbook. It is definitely where the meat and potatoes of data science is. So we'll only get to kind of skim this today. But once you have all the other steps down of learning some R code, being able to read in and wrangle data, the model stuff you can really get going fast. And there's a lot of cool stuff out there to sort of really dive into this field. And then finally, probably the most overlooked step in this whole kind of workflow is communicate. So we also have to be able to communicate our results. It's great to be able to, predict breast cancer with 99% accuracy in a notebook on your local computer. But if you can't express how you did that to others, it's not really going to help anyone. So there's different ways you can do it. I would kind of split it into 2 major categories. One is writing like a report or a paper and getting published at a conference, kind of the academia route. And also a great thing to do and be able to write about your results is really important. Another one you might find at a company is taking your results and making them accessible to other developers. So for example, you could take a kind of machine learning model you wrote or something more data science-y, and then publish it to an endpoint. And if you're not sure what an endpoint or API or those terms, there's lots of great workshops at Hack the North to cover that, so I won't dive into it too much. But basically, you're just letting other developers use your results. Also being able to produce a chart that's accessible by your CEO or some other CXO. Those kinds of skills are really important in being able to communicate what you find. So this, in a nutshell, is data science, everything we just walked through. And so our goal for today is to do a very short version of that to kind of give you a sense of what the field is like and if it's something you'd be interested in learning more about. And then also give you the tools at Hack the North to be able to make a project that is using data science in some way. So yeah, that's the goal for today. So one thing you might have noticed is I haven't really talked about R. I did mention it a few times in walking through that, but nothing about that workflow necessarily is about R. Theoretically, I could do it all by hand, maybe except the model part. But if you're being really technical, maybe you do some fancy math. But for the most part, it's sort of software agnostic. However, R is a really great tool for speeding up a lot of that workflow and is very powerful. You might have used Excel before for doing similar things. say you might have had a science lab report where you made a graph and included that in kind of a document, and that's great. And Excel is good for somewhat simpler tasks. R allows you to go a lot further and do things like making models, and also allows you to do a lot of the things like producing charts and get a lot of customization in there and make it like really powerful. So that's the whole goal of R. There are other great alternatives to R, like Python, which I know there are other workshops this week on, so feel free to check those out. Or Julia is a language that's growing quite quickly. So you can check out those things as well to kind of round out your data science knowledge. R is definitely the one you'll see in school, I think the most, definitely in a statistics classroom, and is surprisingly powerful and easy to use. There's some great tooling around it that we'll dive into today. So as I kind of touched on, you might be thinking, okay, R sounds a lot like it can just do what Excel does. I already know how to use Excel. But there's a few cool things that we can do, like processing data that's like gigabytes or like petabytes large. That is really only plausible in R, unless Microsoft has really beefed up their Excel spreadsheets. Using that many rows of data just isn't really a good idea in Excel, but it's completely fine in R. And then also, it's impossible to use Excel in production, right? You could not kind of deploy your model using Excel, to the best of my knowledge. And if you can, I'd love to be linked into that because that sounds quite cool. But R, it's feasible to do so. And with Python, it's like really easy. So there's lots of different ways to deploy a machine learning model when you do it in code. Last thing I want to touch on too is just kind of the expressivity of programming visualization with R. You can really make amazing graphs and different diagrams. So if you're into charts as much as I am, I highly recommend you go to the subreddit Data is Beautiful. These are just a few examples I pulled from that site. And you can see just kind of like the power you get. Making these in Excel would probably be very, very painful if it's even possible. So yeah, this is kind of the general of what's possible using R, and kind of where I hope to get to and where hopefully you hope to get to far beyond this workshop with a ton of practice behind you. So without further ado, that was about 20 minutes, kind of a brief overview of data science. Now I want to get into the actual programming side of things. So what I'll ask is that you head to a website called Google Collab. Before I talk too much, I'm going to switch to Google Collab in just what I'm screen sharing, so you can kind of follow along with me. So I'll stop sharing for just a brief moment, and then I'll just type in Google Collab to show you straight from Google you can get here. So let me share my tab. Awesome. Okay, so you can see here, I've just Googled Google Collab, how meta. I'm now going to head to the site. And you can see here, I'm presented with a few options of what to import. I am going to flip to the GitHub tab. And once there, I will head to the search bar, type in Michael from YEG. I'll give you a second to do that. Hit the search bar, and all of my unfinished projects will come up very embarrassingly. And you can scroll through those, and you want to look for one called Data Science for People in a Hurry. So I'll give you 30 seconds or so to do that. So again, go to Google Colab, click on the first link that comes up, head to the GitHub tab on the top here, and then type in Michael from YEG, my GitHub username, and search for this repository. And once you're there, just pause for a brief second. Okay, so hopefully you've had a chance to do that. Then you want to make sure to click on collab.ipynb, not workshop.ipynb. So make sure to click on Collab. Once you click on that, you will be taken to the workbook for today. And I'm going to zoom in a little bit, but this is hopefully what it should look like. Hopefully it's a bit easier to read. Just want to make sure it all fits in one screen as well. There we go, that should be good. So this is our workbook for today. So what I've given you all is kind of a place to write out our code right away. There's no environment setup required. This interface is very familiar to what's often called a Jupyter notebook. It's a combination of text cells and kind of images. You can see here, you can write actually any HTML in here alongside code. So you can see here, there's a bunch of code going on, a lot of different stuff. So we can mix these together in a notebook, which is really cool. And that's really powerful because then you don't have to be bogged down by trying to figure out your setup. It's all broken, et cetera, et cetera. So yeah, once we're in here, we'll be good to go. The way different code blocks are broken down in Jupyter is into what are called cells. And individual cells you can run. So you can see this play button here beside this cell. If I click it, okay, it's gonna give me a warning. Don't worry, you can trust me. I'm not gonna put a virus on your machine. So click run, and it will take a second. And I think it's also, you can see up here, just connecting to some sort of, server from my code to run on. And once I run it, I get this green check mark, which looks great. This one, you can see I can import all the libraries for today, and that will take a brief second, and then we're good to go. So that's how to get started with sort of Jupyter. If you have any questions about it, feel free to just throw them in the hop-in chat or on Slido. But it seems like we're all good for now, which is great. So without further ado, I'm going to start working through this workbook. If you think I'm going too slow, feel free to just work ahead of me. Though, everything I'm about to say is also contained on the workbook itself, and you can just run the cells, and there are tests included to help you know if you got the right answer or there was a mistake. And if you did have a mistake, feel free to post again and ask me a question. So yeah, feel free to work at your own pace, but I'll make sure to keep us moving along as well. There's a few different links and resources linked here that I'll go over at the very end. But for now, let's dive into some real code. So we want to get started with R first. R can be a bit tricky to read, especially if you've never seen a programming language before. So we're going to cover some basic syntax for today, and I will move a little bit fast through the section, I recognize. So don't worry if this is all new to you. You get a chance to practice all the basic syntax concepts throughout the workbook. So the first concept to talk about is variables. Variables are how we hold on to data within R. They can, of course, change. They can vary. They're called variables. And we can use them anywhere in a program, even in a later cell, once we make them. We have to decide two things with the variable. On the left-hand side, we pick a name. So here I've picked X. And then on the right-hand side, I have to assign some value, like 5 plus 4. So if I run this line of code, or sorry, this code cell, then you can see 5 plus 4 just outputs 9. But when I save it to a variable X, then if I print it, which is a bit of a foreshadow, you can see I get 9 again. So I've saved 9 into the value of X and done that here. This arrow syntax definitely is a bit wonky. Most languages do something like equals, and you actually can do equals in R as well, like y equals 6. That will work fine, but the arrow is generally preferred, so I recommend you do that. More often than not, you're going to want to print data that's stored in a variable. So this is two different ways to do that. One way is just to leave the variable name kind of on its own line. And then the other way is to write the word print, and then these kind of curly braces, and then the variable name. So you can see both of those output, and I also can output x plus 2 or x plus anything, all different kinds of stuff. I could even print text. And the way I print text is by wrapping it in quotation marks like this. So I could print hello. That's also completely fine. So it's your turn now. In this cell, I want you to create a variable y that's equal to 7, and a variable z that is equal to the sum of x plus y, and then to print z. And I'm going to move through this right away just to kind of keep us moving along. I know these exercises towards the front are a little bit simpler, so I figure we can just do them together to get into the real interesting stuff. So this one, we want to create a variable y, that's the name, set it equal to, with the arrow, 7. And then also a variable z that is equal to the sum of x plus y. So you can see how I can kind of reference the variables by just using their names. And then finally print z, and there's two ways you could have done that. You could have just written z on its own line, or you could write print with the brackets and then z. So I can run that, and you can see hopefully z printed out twice, which is great. And I have these tests included, as I mentioned, and if they both pass, nice, we get some very wholesome emojis. So things are going well so far. First test passed. The next cell asks us to change the value of x, and then does the value of z change y or y not? So let's take a look at that. So let's say x is now equal to, say, 0. If you think the value of z will change, then think about what it would change to. And if you don't think it would change, why would it not change? I'll let you kind of stew on that for just a brief second. So one thing to know about kind of what happens on the right side is that when we write something like x plus y, this becomes an evaluated expression. So in this case, x is 9, y is 7, this equals 16, and then we end up with z equals 16, like that. So when we change the value of x down here, right, set it to 0, and the test pass, if I then go ahead and print z, it will remain as 16. It doesn't change to just the value of y. So be aware of that. Okay. So functions is the next concept to cover. This concept is very similar to how it works in math, where you kind of had y equals f of x. We do what's called a function call, or invoking the function. So we want to kind of activate it with a set of inputs or arguments like this. The syntax, I guess you would call it, is exactly the same as in math, where you kind of have a function name. So usually it's f in math. It could be g, h, anything else. It could also be my underscore function. And then you have these kind of round parentheses, and then you have a list of arguments, and you can pass in as many as you want. So here I've defined a function. Don't worry too much about the actual definition, but the name is Fahrenheit to Celsius. It's going to convert a temperature in Fahrenheit to a temperature in Celsius. So you can see here when I call it, so I'm invoking it with the argument, the parameter, the input, all those words are interchangeable, of 32, and I save the value to how hot, I print it, I get 0. So just to rerun it, you can see here, boom, I get 0. So it looks good so far. This cell asks you to call the print function twice, first with the number 5, and second with the value hack the north in quotes. So again, this one we've actually even seen before, but now you know that you were calling a function, so a little bit fancier than maybe you thought. I can do print 5. You can see I can print a number, no issue. And I can also print hack the north, like this. So again, these are two just kind of basic invocations of a function. So nice and easy. All right, so looks like everything is going well so far. I'm just going to take a peek and see if we have any questions thus far. Okay, I had one person who couldn't access the GitHub file. If you head to Collab, I will type in the chat what to type in to search. So first you want to search for that username, and then you want to look for a hurry. Okay, so yeah, once you head to, I can actually pull it up again just to get everybody sort of on board here. Share my screen again. All right, so once I'm in Collab, if my screen can pull up here. Sorry about that, just a second, just trying to add my screen share to the actual screen so you guys can see it. So from the main kind of Collab page, you just like Google Collab. Once you pull it up, then you want to go to the GitHub tab at the top here. Type in, it's Michael from YEG is my GitHub username. Hit the search button, and then find data science for people in a hurry. So there it is. So Michael from YEG, and then the repository, Michael from YEG, data science for people in a hurry, and you want to open collab.ipy.nb. So let me know once we're all there, should be good. Yeah, any questions, feel free to just post them again, and I'll make sure to answer them right away. So I'm going to switch back now to my workbook. Awesome. So the other question I had is somebody asked, what does the kind of square brackets represent? I can't remember exactly where we would have seen that, but it's a good question regardless. Oh, I see, with like the prints. Oh, that's a good one, actually. I'm not totally sure why when we print something, it kind of comes with these square brackets attached. So yeah, don't really have a good answer for that one, but for whatever reason, when we run print, instead of just kind of leaving the value. Like you can see when I just put the value, there's nothing. But when I run print, it includes this kind of extra thing. Don't really know why. Doesn't seem the most helpful, but I think it's different even in Jupyter. So yeah, good question though. Could you repeat how to run the notebook? I can access it. So somebody asked, could you also repeat how to run the notebook? For sure. So once you're kind of open the notebook and you're in this interface, all you have to do is just click the play button on any of the cells and they will run. You can also use this tool up at the top to run all of the cells. So if you go to the top, you can click runtime and then run all, and you can run the workshop just kind of top to bottom. But otherwise, yeah, I recommend just kind of running the cells one by one as you kind of work your way down. So yeah, hopefully that was all the questions for now. Everybody's on board. I know, again, moving a bit fast, but you'll have lots of time to practice this throughout the workshop. So the next one to talk about, so we've covered functions, right? Invoking a function, you just kind of write the name of the function, curly parentheses, and then whatever you want to pass in, exactly like math. The next one is on libraries. So libraries are built-in sets of function that we can import into our notebook. So what does this mean? Well, so for data scientists, Rome wasn't built in a day, neither was a data scientist notebook. We don't want to have to implement every single thing we do from scratch. So for example, if we're relying on some kind of helper function to help us produce a model from our data, or a function to help us produce a visualization from a data set, we don't want to have to write in all the little bits and pieces of code to make that working every single time we start a new project. So instead what we do is we install some code from the internet and we kind of import it into our workshop, and then we can act like we've defined all of those functions within our workbook already, which is really awesome. So you can see here, a quick example, I can install a package called dplyr, and then I write library, which is kind of a special function for importing a library, and I pass in the name of the library itself. So you can see here, it's telling me it's installing the package, and that does take a little while, unfortunately. And then eventually, once it's finished, it will import it. One thing to pay careful attention to is that when I do install.packages, I have to wrap it in quotes. But when I do library, I don't wrap it in quotes. Why that is, not totally sure. A bit of a weird kind of quirk, but do be careful of that when you are trying to, you looked up a package from the internet and you're trying to install it. All right, so it looks like this cell has run, so library was imported, which is great. This one asks us to do something similar, but with a package called caret. So again, fairly similar to what we've just seen. All we have to do is call install.packages with caret, caret, and then do library with caret. And again, just click the play button to run the cell. And you can see it's installing a bunch of dependencies, and it will eventually load that in. And once that's finished, I can try running this cell to check that that library has been imported. Again, so these are kind of the basic things you'll need in R, being able to store a variable and print a variable, being able to call a function, and being able to import a library to do actually quite a bit of work in R. So hopefully that all made sense. And if you do have any issues, feel free to post in the chat. While caret is installing, I'm going to move on to reading in a data set. So once we have a file available to us, we of course want to read it into our notebook. So you can see here, I call a function called read_CSV from one of the libraries we imported, and I pass in this case, a URL that links to the file. So if I open this URL, you won't be able to see it, unfortunately, when I switch tabs, but feel free to give it a go yourself. I'll be able to see kind of the raw data that we're about to import. So feel free to give that a go, copy and paste that link into your browser. When I run this cell, see, it takes a second to kind of download the file from the internet and sort of parse it, all the different values. And again, this is just something you could open directly in a spreadsheet, nothing you probably haven't seen before. But once this is finished importing, I'll get a quick summary about kind of the data that I've just read in, and then be able to start working with it and taking a poke at what's included. Seems like it's taken a little while, so maybe that's just Google Collab. Too many people in this workshop, I guess, and it's slowed down. But I'll give that a second to load in. And then once that's finished, I will print out the data. Again, two different ways of printing out any data set. I take the variable name and I just kind of write it directly, or I can call this print function and pass it in. So cell is already running, so that's good. We'll keep waiting a brief moment for that to import. While it's happening, we'll keep moving on, and hopefully we'll be able to come back and write the test. You know what's probably happening is that because I'm installing the package at the same time, two cells can't run together. So it's waiting for this to finish. I'm actually going to go ahead and interrupt this cell just because it's going to complain and complain. That's okay. So that's how you import a library, but obviously that was a bit slow. No worries at all. Let's instead jump to this cell and read in the data set. There we go. You can see we have 2,200 rows and 14 columns, which is great. And I have a bunch of different columns read in here. See institution, country, world rank, national rank, and so on. On this note, the data set we're working with is university data. So there's a number of universities like Harvard, Stanford, U of T, UBC, my home, and some other universities in this data set. And it contains ranks for the universities in a number of different areas. So for example, it contains rankings of the quality of education at each school. So 1 is like the best school and 1,000 is the worst school. So be careful. Just because it's a higher number doesn't necessarily mean better. There is one column where a higher number is better, and that is score. The score is based on a scale of 100. So a 100 score is a perfect school. Everything is the best it can be. And 1 is the worst score you can get possible. So that's the data we'll be working with today. If you want to go look at it, feel free to click on this hyperlink and it will take you to Kaggle, the website I pulled it from. But without further ado, we've now imported the data. We should be able to print it. And you can see here, I've got a whole whack of data. So there's rows and rows and rows and rows and rows, and see different columns along the top and citations, influence, publications, all things that are ranked for each of these universities. And let's just double check that was read in, and it was. We get a nice little cat smiling, which is a good sign. So there's an issue with how we printed this data. And the main issue is that there's just so much to look at. I can barely fit it on my screen. I am zoomed in a little bit, but it's just quite overwhelming as it is. So instead, what we want to do is just print the first 6 rows, just to give us a quick little glimpse at the data rather than seeing the entire thing. So I'll give you a moment to try. You want to call a function called head, and you want to pass in the variable university_df, which is where our data is saved. So take a brief moment and try doing that. Again, if you're stuck, feel free to look at the earlier code we used to call a function. And once you're finished that, feel free to just chill out for a sec. So hopefully you had a chance to do that. It is pretty quick, only 1 line of code. So the function is called head. We do the round parentheses again, and then we pass in university_df. And so you can see now I get a much more easier to look at set of data. I just get the first 6 rows, and I can see all the different columns associated. So world rank, institution, so on and so on. So that's awesome. The next activity asks you to read in a different data set that is about eruptions of, what is it again? It's like some Old Faithful. So the geyser Old Faithful, if you know, erupts very often. And so this data set asks you to look at that data. So feel free to read in the data from the value at this URL, and then print it out again just to check that you did it right. So again, I'll give you a moment to do that. And again, if you're stuck, always encourage you to look at earlier examples. So remember, this is how we did it for the university data frame. Saw a really good question come in while you guys are working away at that one. So you can see here when I've read in the data, we got 2 different kind of weird words come at the beginning, CHR and DBL. So these refer to the types of the columns. So you can see already in R, we worked with a number of data types. I haven't really talked about it very much because it's kind of beyond the scope of this workshop, but there's been things like numbers. So 1, 2, 3. There's also been strings, which are like hello and world, right? Where we wrap them in quotes and we write something down. And then aside from having numbers that are kind of like single digits and whole numbers, we can also have decimal points with them. So I can have 3.14, right? And so these CHR and DBL are referring to the data types. It's saying that institution and country are characters, meaning they're strings, so kind of like hello and world. And DBL, these columns are all numbers. So that DBL is short for double, which if you've ever done any programming in Java or C or anything else, you might have seen this kind of terminology before. So yeah, good question. Hopefully at this point, you've all had a chance to read in the data set. I will now go ahead and do that quickly. So I'm going to do read CSV of the URL directly. And it says I want to save that to a variable called Old Faithful. And it's good practice to always take a peek at what you read in. So I'll run that. And you can see I have 2 columns here. They're both DBL, so both numbers, eruptions, and weighting. Run the test, and we pass, which is great. And now instead of printing the first 6 rows with head, we can do a very similar thing with tail. So all I do is plug in head instead of tail, pass in university_df, and we can see that there, which is great. So now that we've been able to read in our data, our next task is to process our data. So we process our data in a number of different ways. The first one I'm going to cover is by using something called filter. So I have to introduce a new data type to talk about this, which is Boolean. Boolean means true or false. So it's one of those 2 values. And we can use logical operators like exactly equals, greater than or greater than or equal to, that kind of, all those kinds of operators to produce Boolean values from 2 different things. So we can compare numbers. That's what I've done here. And you can see, 3 plus 3 equals 6. Yes, those are the same thing. So it prints true. Whereas 3 plus 3 does not equal. That's how you do that in programming. Does not equal 6, and we get false. So I ask you here to write out, I'm just going to go ahead and do it because we're running a little bit short on time, to write 5 equals 4 and 5 equals 5. When you do this, you can see we get false and true, and they're in all caps. I want you to pay special attention to that because in some languages, it's written like false with a capital F. In JavaScript, I believe it's all lowercase. So be careful that when you're doing R, it's all caps lock, false. We're going to skip this next exercise, but feel free to give it a try on your own just for some extra practice with Booleans. So you can see here, I've applied that knowledge of Booleans to write a filter function. So the way I can filter down a data set is to call this thing called filter. I pass in my data as the first argument, and then I need to pass in some expression that results in true or false. So what I did here is gave it a column name, national rank, and I said, okay, look at each value in column name, and if its value is less than or equal to 2, you can keep it. Only keep things that are true. Then I printed it out. So when I run this, you can see I end up with the top universities in a bunch of different countries. So I get Harvard, MIT, Cambridge, University of Tokyo in Japan, which is really cool. So I can also do, say I just wanted all the top universities in the respective countries. I could do national rank less than or equal to 1, which is of course just 1. And you can see there, U of T sneaks in as the top university of Canada. There must have been an error in making this data set, of course. All right. So from there, let's try filtering all the rows where the country is Canada. Let's see all the Canadian data. So I'm going to copy this from above, and I highly recommend you get used to doing this because what you'll find when you start doing a lot of R programming is that there's a few patterns and you use them all the time. So get used to using copy and paste. It doesn't mean you're cheating. It's just a good way to speed things up a little bit. So I want to know where country is exactly equal, double equals, to Canada. And I'm going to save that to a variable called Canadian Universities_df. All right, so let's print that out. And you can see U of T, McGill, UBC. Now, one thing you might notice is a bit strange is that there's actually duplicates of each university. So there's U of T and then U of T again. And the reason is because if we scroll all the way to the right, each university is represented for multiple years. So we have data from 2012, 2013, all the way up to 2015. So do take note of that. Let's check that we did that correctly, and we did, which is awesome. So that was your first filter. A similar operation we can do is called selecting, where we limit the number of columns we want to use in our data frame. So in this example, I have a university underscore small data frame, and I select only the columns called institution and country. One thing to note is that I'm not passing in strings. So I'm not going like this and saying institution, right? I'm using just the literal characters institution. And I can pass in as many columns as I want. So if I wanted to add back, I don't know, like national rank, I believe it was called, and I could do it as such. And there we go. Now we have national rank as well. I'll give you a second to try out this exercise. It says use select to only select national rank, world rank, and year from the original data frame, and save that to a variable called university select df. So give that a go. And yeah, I'll wait a minute or so for you guys to finish. All right, so hopefully everybody had a chance to try that one out. Again, copy and paste is your friend. So let's use our earlier example, but this time we want different columns. We still want national rank, but instead we also want to include world rank and year. Awesome. And then we'll just print that out because it's good practice, and I'll wrap that in a head. And there we go. So we can see we got national rank, world rank, and year. And let's check that it's selected correctly. Great, the test passed. So TLDR, all that section, that was what we usually call wrangling. There are, as I mentioned, other operations you'll probably want to do, and I recommend you check out after this workshop, like mutate, group by, and summarize, gather, and spread. And they do mostly what they sound like they do, but again, you have to read more to learn how they work. Now, we want to produce a visualization of our data to really explore it. The way we do this in R is by using a really fancy function called Ggplot. So the way that works is, well, first I'm going to filter down to just 2015 data. And here is a basic piece of code to produce a scatter plot. So you can see it's already been run. I'll just rerun it quickly. So you can see I pass in the data frame to this function called Ggplot. I do some weird stuff here where I'm sort of calling another function inside Ggplot. We'll get into that in a second. I have a plus symbol, which is kind of strange because that's usually for adding two numbers. And then I call another function called geomePoint. So there's a lot going on here, and I recognize it's kind of a big jump in the workshop. But again, you know all the fundamentals here. You know there's a function called Ggplot, there's a function called AES, and there's a function called geomePoint. I pass in this as an argument. I also have to call AES and pass it in as an argument as well. And then the plus symbol, okay, that's a little fancy. We haven't covered that yet, but I promise I will get there. Then I print out the plot just like normal, and you can see it here, and I get this very pretty plot. That makes sense because as universities have a really small world rank, like rank 1 in the world, they have a really high score, like 100, right? So that's just how to read this. So AES, that kind of inner function we're calling, is short for aesthetic specifications. It is a function that accepts the X and Y columns we'd like to use. So I want you now to create a scatter plot with quality of education along the X-axis and quality of faculty along the Y-axis. And I'll do that along with you. So let's copy and paste the starter code in. We want to call it quality plot. And again, we're going to pass in these two column names. So you can see here, X originally was score. I'm now told I want the X-axis to be quality of education. And for Y, quality of faculty. And you can see here, the data isn't really related very much, But as I get into schools that score really well on quality of education, they're like the top ranking schools, they also have the top ranking faculty, which makes sense. But as I deviate further away, I could have really good education and bad faculty, or I could have really good faculty and bad education. So something interesting there. This cell asks you to use the exact same code, but now we change geom_point to geom_violin. And I'll show you what happens. It's quite interesting. So as you might have guessed already, a geom_point produces a plot with lots of points. Geom_violin indeed produces a plot with a violin distribution. It's kind of like a box plot, if you know. I won't get into the nitty-gritty of this, but we can change the kind of plot we're producing, doing things like geom_bar, geom_anything. And all of the geom_anythings are listed at this URL. So feel free to check them out and kind of have some fun with that. That was our first visualization, and I'm now going to show you what that plus symbol means. So here's a really complex example that includes y-axis and x-axis, this kind of line of best fit, if you've seen from probably like a physics course or something, with a bunch of plus symbols, right? So if we run this, we get indeed the chart that was shown. And that plus symbol is something special about the ggplot function. It lets us add layers to the plot. So we can add layer by layer and make our plots more and more complex. So when you want to add more dots, you want to add a line of best fit, or you want to add labels, the way you do it is by that plus symbol. And yes, it looks like it should be adding two numbers, but indeed with ggplot, it's kind of overridden, and instead it will just add kind of new, you can think of it as kind of literal layers on top of one another that will form our plot. So in this example, I'm going to have to do it with you because we are running short on time. It asks you to take basic plot and add, make the font size 60. And so if you look at this previous example, you say, okay, this geom point, that adds the points. X label, X lab, Y label, Y lab, GG title, of course, adds the title. Then there's geom smooth, that adds the line of best fit, and I commented that in for you. So the only remaining choice is theme. And here we kind of customize text and we say size equals 15. So I'm gonna grab this and I'm gonna change basic plot's theme to be 60. Now you can see, whoa, really big text, right? So you can see I didn't have to remake a brand new plot. I didn't have to call it ggplot again. All I had to do was do the plus and add new theme, and I could add layer by layer by layer. So it's really easy to just quickly modify plots in R or add more detail to them as you go, which is really powerful. Okay, last but not least, I'm going to very quickly go through your first model. This requires a little bit of math knowledge of y equals mx plus b. If you haven't seen it before, you can take a pause after the workshop and slow down. And you can take a look at this and it will make a bit more sense, but I'm going to go on the assumption that you have seen that before. So we want to look at the relationship between quality of education and overall score. So what we can probably guess is that for universities that rank higher on quality of education, their score is higher. And indeed, that's true. You can see as I start to get into the top quality of education schools, the score goes way, way up all the way to 100 all of a sudden. So what we do is we can add, like we did before, geom smooth, which is kind of this line of best fit that goes through kind of the middle of the points, as middle as we can be. If we print that out, we can see, yeah, it looks okay. It hasn't perfectly captured the relationship because this data isn't exactly linear, right? But okay, it's an approximation for now. And you can see it's more accurate as we get into higher qualities of education, schools that rank much lower. So indeed, there's the y equals mx plus b stuff. Take a look at that if you need, but I'm going to continue on. This is the piece of code to produce what's called a linear regression. All that means is the y equals mx plus b equation for this blue line. So once I run this piece of code and get the equation for that line, you can see I can get an intercept, which is where the line will intercept the y-axis, the score, which is actually, in fact, the slope of the line. Then with those two things, I can plug in a new value of x and get a new value of y, right? Kind of the most simple model you can have for data that is linearly related. So For example, say I have some imaginary school, I think its quality of education will be 50 ranked. So it's like the 50th worst or 50th best, I guess, quality of education out of the universities studied. Then I can predict what score it will get by using the y-intercept plus the slope times my new value of x, which is 50, and I get 268.5. So there we go. I made a prediction with data I've never seen before based on a model I produced from a data set that I read in entirely using R. And I know that was extremely fast, and it takes people years, of course, to cover this stuff, but hopefully that gave you a high-level sense of what the field is like. Today, we managed to cover some basic R syntax, import data, explore a data set, visualize data, and produce first model. And there is a bit more linked down here about different models you can produce and how to take this, export your graph images, and also kind of export your model, and then use it with teammates at Hack the North. So that's all, folks, for now. I will go back to the slides quickly, so don't jump away just yet. I'm going to reshare my screen quickly here. Just a few more things to touch on before I let you run. So to have these concepts stick, we definitely want to try to apply them this weekend to Hack the North. So try creating an API to do some kind of prediction, like house prices or whether or not you'll get into university based on like your high school grades and your extracurriculars. Perhaps you'll create graphs for your pitch deck, or even create graphs to like supplement a business model, for example, projecting growth. All cool applications of what we've learned today. Why data science? Well, data science is, according to the Harvard Business Review, the sexiest job of the 21st century. It's growing like crazy, especially, software engineering as a whole is growing like crazy. So is data science. And data scientists do get paid quite handsomely if you're into that kind of thing. And if programming isn't really for you, it's a great option to look at. So feel free to check it out. Of course, there is some programming, but it's not as coding heavy as something like software engineering. But of course, the best way to learn data science is to do data science. So the one thing I want you to take away from this is to get hands-on, go on Kaggle and find different resources, go online and Google different tutorials, things you can try out, and get programming. That was the goal of today's workshop, and hopefully you feel even a bit more comfortable. I know I did have to go fast, which is unfortunate, but hopefully you feel just a bit more comfortable with R and feel like you can go places with the stuff we learned today. I linked a few resources here. I encourage you to check them out. A specific one I want to highlight is a first introduction to data science. It's this third one linked here. It's a free and open source textbook from UBC that kind of gives a very practical introduction to data science with R, and you get to create a lot of different cool models. So I highly, highly, highly recommend you check that out. With that, thank you. Any questions, feel free to direct and I will answer them. But yeah, number one thing I want you to do before you head out is to please fill out the survey about this workshop. Your feedback is super important to me. Of course, looking to always improve. I've had a chance to run similar content before. I've TA'd a bit, but feedback about how I'm explaining certain concepts and things is always super appreciated. And we'll go on to make future gear up events much, much better. So yeah, hugely appreciate you guys filling out that feedback form. If you have any questions, feel free to send them over. I'm at Michael from Yeg on just about every platform, so feel free to connect with me there. Facebook, LinkedIn, GitHub, Pigeon Mail, it doesn't really matter. Feel free to reach out. And yeah, look forward to seeing you all at Hack the North this weekend.